Hello everyone, and welcome to today's video about the basics of scripting in Unity using C#. So this video is going to be directed as though, with the expectation that you guys already understand some programming, because we all have had Intro to Programming taking this course. So we're going to go over some similarities between C# and Java today. And basically this entire video is going to examine C# and how it relates to Java, the things that are the same, the things that are different. And hopefully most of this should be review to us, because C# is very, very similar to Java in a lot of its basic syntax. It's part of the reason why we're choosing C# for this class as well. As you'll see in a moment, C# is not our only option for creating scripts in Unity, but it's the one that we're going to use for this course. So to get us started today, I've created a cube, I've created a scripts folder, and I've created a script already called reporter. And I've done that simply by right-clicking, going to create, and then a C# script. We also can use JavaScript. Common misconception, JavaScript is not Java, and it shares very few similarities with Java, so we're not going to use it for this class. C# is actually much closer structurally to Java than JavaScript is. So I created a C# script. It came with a default name. I changed that name to reporter because we're going to be using this to print out some stuff to the console. So this is kind of like we're starting with Hello World all over again, but we're talking about how it relates to Unity. So let's take a look at the script. We do not edit C# scripts in Unity. Unity will give us a preview of what is in the script, and we're going to talk about all this stuff in a second. But where we actually edit our script is, depending on the platform, an external editor, and in this case, when I double-click this guy, it's going to open Visual Studio. Now, whatever editor Unity is going to use, whatever editor Unity is going to use comes bundled with Unity, so you don't have to worry about installing a separate program. Unity should have done that for us. So in this case, Visual Studio, if you're using a different editor or if you're using a different platform, for example, I'm on Windows. I'm not sure if the editor is the same on Mac, so your editor may look different, but the process we're going to follow is the same. So basically, we're going to be editing our scripts in an external editor, saving them, and then using them in Unity. So let's talk a little bit about what we are looking at here. Some stuff should immediately be familiar to us based on our Java education. Public class reporter. We should recognize this right away as our class definition, right? And if you've only taken intro and not intermediate, then we haven't talked as much about classes, but this is our container, right? This contains all the code for the reporter class. In general, a class corresponds to an individual object in the scene. We're going to talk about that in a little bit. This is Unity or C#'s way of importing stuff. So in Java, we would say import whatever. And we would import a package. In C#, we say we are using what is called a namespace. So same idea, just a different convention, different syntax. And then hopefully, we recognize these guys as methods. Notice that there is no main method in Unity or in our Unity classes, and that's because there are a couple of methods that are automatically called for us, and they're not called main. So we're going to talk about what each of these guys do. Before we jump into actually writing some code, though, there's one more piece I want to point out to you, and that is this : MonoBehaviour. MonoBehaviour is another class in Unity, and a MonoBehaviour is basically a class that defines everything about a script that's going to be attached to a Unity object. We call this a base class. If you guys had the full year of Intro to Computer Programming, then we talk about inheritance and extending stuff. That's what's going on here. If you're not familiar with inheritance, or if you haven't gotten to that yet in your Java lessons, then this is going to be a little new, but we don't really need to worry about it. All we need to know is that MonoBehaviour has some code inside of it that reporter is leveraging. So MonoBehaviour is allowing us to not have to write all of the code ourselves. It provides a basis for us to work from. This : just means that reporter is a MonoBehavior. It's getting everything it needs from the MonoBehavior class. For those of us that have done inheritance in Java, this would be the same thing as saying reporter extends MonoBehavior. But we don't have extends in C#, we have a colon instead. Means the same thing. So I've started some notes here, and the first note I have is that every script we write in Unity extends MonoBehavior. And again, that's to make our jobs as programmers a little bit easier. The MonoBehavior class has some code inside of it that we can leverage. Part of that behavior is knowing when to call the start methods and the update methods. So start is kind of like our main method. Start is the code that we want to run when our game begins. Now, the interesting thing about this is we can have many different scripts attached to many different objects, and we're going to look at that in a second. But the start method gets called at the beginning for every script that we have. So I make a reporter script, I put code in my start method, I might make a different script for a different object, and that start code gets called at when the game is started. So I'm going to kick us off here with something that should look pretty familiar. In my start method, I am going to write print, and then in quotes, hello world. All we're doing here, just like in Java, we're calling a method, right? We're calling a method called print, and we are passing that method the hello world string. Notice that printing stuff in C# is a little bit more concise than in Java. We don't have to have system.out.println. We just say print. And this prints out whatever we put in the parentheses to the console. So again, slightly different syntax, but notice all the similarities, right? We have a method name that we're trying to call. We have open and close parentheses. We have a parameter, right, inside those parentheses. And we have a semicolon at the end. Very, very similar. So let's see how this actually works. So the start method should be called at the beginning of the game. So I'm going to save this. Let's make a couple of notes here. Start method called when the game begins. So all of that code is going to get run when we start the game. If we go to our console, this is where, I'm going to clear this. This is where our output goes. So again, just like in Java, whenever we call print, it doesn't actually put anything on our screen. Print is just printing out to the terminal, or in this case, to the console. So if we hit play, hopefully we'll see hello world. And we don't. Why not? So we don't see hello world because even though this script has been created, every script needs to be attached to a game object. Typically, a script is attached to a game object whose behavior it's going to modify. So for example, if I wanted my cube to do stuff, I would create a script detailing what the cube should do, and then I would attach the script to the cube. Now, our reporter doesn't really do anything object specific, right? All it's doing is printing out stuff. It doesn't care if it's attached to a cube or a camera or a light. So I'm just going to attach it to whatever I want because it's going to behave the same way no matter what. But it needs to be attached to something. Right now, the script is hanging out in my assets, but it's not a part of my scene. So I could create a new empty object, I could add it to that, I could add it to the camera, but since I've got this cube here for demonstration purposes, I will add this script to the cube. So all I'm going to do is take reporter and attach it to my cube. All I did was drag it into this add component section. If I wanted to, I could select add component, I could go to scripts, and I could choose reporter as well. Either workflow works, but obviously I find if you've got it over here in the project inspector, you might as well just click and drag it over. Now the reporter script is attached to my cube, meaning that when I run the game, the cube's going to say, oh look, I have some stuff I need to do, and it'll run that stuff. So let's try it again. And now we get hello world that prints out of my cube. All right, so let's take a look at the other method in my MonoBehavior, or in my reporter class. So the other method that's provided to us by default is called update. Update is called once per frame. I'm going to add a note here that says 60 times per second, because by default in Unity, our frames are 60 frames per second. So every 1/60th of a second, whatever code I put in update gets called. Hopefully it should become evident that that should mean that I'm not doing a lot of changing on the screen, because if I were, then I would see a lot of stuff being done on the screen at once, and I don't want that. I want to make sure that update is only doing what needs to be done every 60 times per second. However, we're gonna get a little crazy, and we're gonna stick another print statement in here, and we're gonna say every frame. Then we're gonna go back over to our MonoBehavior, or to our project rather, and notice something. Notice that if I go into my assets and my scripts, this hasn't actually been updated yet, right? My update method is missing stuff. That's because my editor and Unity are separate programs. Unity doesn't realize that I've made a change to this file until I save the file. So you guys haven't seen it, but every time I write some code, I've been using Control-S or Command-S on a Mac to save my work. And in Visual Studio, there's a clue that shows you that something's not saved because this green bar turns yellow. So if I add stuff, notice that this is yellow now. This is saying this particular content is out of date and has not been saved. So I want to make sure that I always save so that this is all green. And now, if I go over here, I can see that my script has been updated. Now the nice thing about it is, once a script has been updated, I don't need to drag it onto my cube again. My cube is referencing this script, and any changes made to it will automatically be updated into my cube. So let's go console. Let's hit play. And now we can see we're getting a lot of output. Too much output, right? We're getting output printed every single frame, and that's bad. So let's talk about the last little thing that we haven't really discussed yet, but is super important, and that is variables and control structures. So again, stuff that is very, very similar to Java. I'm not going to spend a whole lot of time on it. I'm just going to show you guys an example. So update gets called every frame. Instead, I want to only print out this message every 100 frames. So I'm going to say 100th frame, and I want this to print out every 100 frames. So I'm going to need a couple of things. I'm going to need a variable to keep track of how many frames I've counted. I'm going to need to increase that variable every time an update is called. And if that variable is equal to 100, I want to print out my statement. So let's talk about our options for making a variable in Java. I'm going to add a note here, update method called every frame. So let's talk about data types in C#. We've got our old friend, the int. These are, again, primitive data types. We have our old friend, the int. We have something like Boolean, but it's called bool. That's what we use instead of Boolean. Instead of a double, we have a float. So int obviously is whole numbers. Bool, true or false. Float, decimal numbers. We still have the car, individual characters. And then the other one that's kind of interesting is we have string, but in C#, string is a primitive type. So it starts with a lowercase s. It's not an object in C#, which also means we don't have string methods. We don't call things like string.length or any of that stuff because string is primitive. Okay, so we have int, bool, float, car, and string. Which of these are we going to use for our counter? Well, whole numbers makes the most sense because we're just keeping track of whole number frames, right? We want to start at 0, and on the 100th frame, we want to print out that this is the 100th frame. So let's make a variable. Now we're going to want this variable to be available everywhere because we want update to be able to update it every single time. So I'm going to create at the top of my class, and this is something that we're going to do a lot in C#, but is a little different to for those of us that are used to Intro to Computer Programming in Java. I'm going to create an int variable, and I'm going to call it frame counter. Not going to set it equal to anything. I'm just going to call it frame counter. And now I need to set frame counter. I know I want frame counter to start at 0. So where is the most appropriate place to set frame counter? Well, in this case, I know that I have a method called start. Let me make a comment here that says keeps track of number of frames. So I know I have a start method here that is called at the very beginning of the program. So I'm going to initialize frame counter in my start method. And notice that Unity inserts a comment for us to kind of prompt us to do this. It says, hey, the start method is where you should do all of your setup, right? Use this for initialization. So initialize the frame counter equals 0. And then I'm going to print hello world just to let the console know that start has done its work. And then in update, got to do a couple of things. The first thing that I want to do is I want to check, did the frame counter hit 100? So I'm going to say, if the frame counter is 100, print a message. And then the other thing I'm going to want to do is reset the frame counter. And then finally, otherwise, I want to increase frame counter. So let's fill this in. The good news about control structures in C# is that they are almost identical to Java. In fact, this one is going to look just like Java exactly. And so oftentimes what you want to say to yourself is, if you're not sure how to do something, how would I write this in Java? Try it. And then there may be some minor things we have to fix. But for the most part, it's going to be a pretty safe bet that the Java syntax is going to be pretty close. So I'm going to say if frame counter equals, still two equal signs, 100. And I'm going to grab this stuff, put it in here, miss that R. Print a message, so we reach the 100 frame, reset the frame counter. Frame counter equals 0. So notice, same convention here, right? Equals means I'm checking if frame counter is 100. Here, I'm setting frame counter to 0, right? So it is 100, print the 100 frame, now start counting, start over again, so that frame counter will increase. You can think of update almost like a loop, because all of this code is going to be called every single frame. So 60 times per second, this code is going to be executed, and it's going to be executed as long as the game is running. So update is kind of like an execution loop. It just goes over and over and over and over again. Otherwise, increase the frame counter. Okay, we know how to do otherwise. In Java, otherwise is an else statement. And notice that all I had to do here was start my open curly brace and hit enter. And Visual Studio is doing some of the formatting for me. So it put the curly braces onto their own lines. It made the curly brace automatically. There's a lot of helpful stuff happening here. So else frame counter ++. Again, same exact syntax. ++ is our increase by 1 syntax. So other than some of the stuff up at the top, other than the name of the method, notice that in C# method names start with a capital letter instead of a lowercase letter. Again, just a minor change. Other than that, this looks just like Java, right? Our if statements look the same, our operators look the same. And that's partly because both C# and Java are based on the same language. They both come from C++. But really, you'll see conventions like this in a lot of different programming languages. There are a lot of languages that follow these same syntax structures. Okay, so I've saved my work. I'm going to go back in here, and this is what should happen. We've created a variable called frame counter. When the game begins, frame counter should get set to 0, and we should print hello world. Then every frame, so 60 times per second, we're going to check if the frame counter is 100. If it is, we're going to print out 100th frame. We're going to reset it to 0. Otherwise, we're going to say frame counter plus plus. So until we've hit 100, the code's just going to go down here and go 1, 2, 3, 4, 5, 6, all the way up to 100. When we get to 100, it prints this and resets and does it all over again. So let's see how we did. Clear our console. Okay, we get hello world, and then we get 100th frame, and we get that every 100 frames. So now we're getting a much more manageable output. And oftentimes what you're going to find is we don't output every time we update. So because it's 60 times per second, we're often not changing the screen 60 times per second. We are often updating internal variables like this, right? We're changing frame counter. And then when a certain thing happens, then we update our counter. Or then we actually print something. When we show output only when we need to, what I'm trying to say, to avoid any extra output that's going to slow the game down. Okay. So that's the basic on scripting. We did some control structures, if-else statements, variables, what the MonoBehavior class looks like. And we're going to basically be using this type of stuff to make all of the behaviors for our objects. In the next video, we'll show how we can actually access some useful information and print that out to the screen. Thanks for watching.